Okay, trig students, we're nearing the end. We got a couple more chapters that we definitely have to get through. Chapter 6 is one of them, Chapter 7 coming up, and we'll obviously start Chapter 6 today. Essentially what's happening here is we're going to start solving a bunch of trig equations. So we've been finding trig values, something like, find the sine of x, given a whole bunch of information. But now what we're actually going to do is figure out, well, what x value, right, will create a value of 1/3 or something of that nature. So we're actually trying to find the angles. We're solving it. We've done this before, especially when we have exact angles. We dabbled a little bit when we talked about inverse trig functions in a previous chapter. I think it was in chapter 2 at one point when we first took a glimpse at this, but it was pretty basic. Now we're really going to dive into the inverse trig functions. And the thing I want to kind of concentrate on when you look in your TI calculator, the three main ones are sine, cosine, and tangent. So since those are on our calculator, those are the three things I'm going to refer to in most of this conversation and throughout my work, because we can always, by using the reciprocal identities, if we have a secant, a cosecant, or a cotangent, we can always convert the equation back to its cosine, sine, or tangent form, and then use these three, and then use our calculator and whatnot. So I'm going to focus on this, on the big three. I do believe the textbook will show you the other three, and if you follow my conversation, you can kind of really truly understand what they're getting at. So let's do some groundwork first. So we know from back in our college algebra days that if I have a function that, let's say, takes a value and creates a b value, the inverse of that function, right, given by f to the -1, that means inverse, will take b and spit out a. So we're literally changing positions, right? So a, b is on the graph of f of x, and b, a is on the graph of the inverse. So there's a little bit of review when it comes to inverse functions. And because of this right here, what ends up happening is that the domain of f and the range of f basically end up doing a flip-flop, right? This becomes the domain of the inverse, and this becomes the range of the inverse. So the domain of the original function becomes the range of the inverse. The range of the original function becomes the domain of the inverse. So they're literally flip-flopping. And what that means for us is what we've been doing, again, going back to the basics, is our inputs are usually some angle, and our outputs are some ratio, right? In this case, it was, let me go back to our x, y, r definition. The ratio for sine was y over r. What the inverse function is going to do, so the sine inverse is going to take that y over r and give us the angle value that does that, and hence we're going to be solving for that angle finally. Of course, what we also found, I think I snuck that at you guys, and we're going to see that a lot in this chapter, is sine inverse also means arc sine. This basically goes back to the idea that when we go to radian mode, right, theta and the arc length are very much related to each other, especially on the unit circle. Theta is equal to s. So there's two ways to write our inverse. Sine to the -1 represents an inverse function. We're basically taking a ratio and spitting out a angle, where we have arc sine doing that. Okay, so and we've seen that with cosine and tangent and secant and everybody else. But again, I'm going to concentrate on the big three. All right, so there's a little bit of review. You can kind of see again the idea that the roles of the input and the output are flip-flopping, right, for this sine function. And then what we also remember from our college algebra days is that in order for all of this to happen, we needed a one-to-one function. And unfortunately, when we think in terms of sine and cosine and tangent, they are not one-to-one. So we have some issues that we have to worry about and work with here. So I'm 5 minutes into this. How about I cut away from this video? We know what we want to do. We've actually worked with this, so we do know it exists. But because we're not one-to-one, we got to kind of address that issue, and then how that impacts our inverse, how that impacts our domains and range, so that we can actually use the inverse in a more official fashion, unlike what we just did. I think it was chapter 2. So let me cut away to a new video. We'll take a look at the one-to-oneness, fix that situation to impact our inverse functions. See you guys in a moment.